I said I was going to do a more difficult problem in terms of graphing on a table, which I'm going to do. Later I'm going to show you a way to graph this without ever using a table again. And that's going to be pretty fun. Actually, very fun when it comes to graphing linear equations. But we're not doing that just yet. What we're going to do is we're going to graph this with a table. And I said that this answer was that this problem was a little bit more advanced than the other one was. I said use the values -2, -1, 0, 1, and 2 for this type of a problem. And as you can see, it's already solved for y, so I don't even have to worry about trying to solve for that. So you get y by itself, I already got it by itself. Here's my suggestion. Whenever you're doing a problem and it has a fraction in it, you want to use multiples now. And what I mean by that is very simple. It's okay to use -2, -1, 0, 1, and 2 when there's no fractions. But if you have fractions, you want to use multiples of that number, of the denominator of the fraction. And it happens to be that the denominator is 2. So I want to use multiples of 2. If the denominator was 3, I'd use multiples of 3. For instance, I can use -2 because it's a multiple of 2. But -1 isn't, so we're going to skip -1. 0 is always a fun one to use. Okay, 1 is not a multiple of 2. Let's use 2. Can't use 3. 4, 6. Basically, if the denominator is a 2, I use -2, 0, 2, 4, 2. Or I can actually stop after 3 values. If the denominator is a 3, I would use -3, 0, 3, 6, 9. If the denominator was a 4, I would use -4, 0, 4, 8, 12. I would just use multiples of it. Like I said though, it's a more advanced problem. And that step actually makes it considerably more difficult for students to graph. And they see fractions and they want to give up. Well, it's not about giving up. It's about trying to persevere under pressure. So here's what we're going to do. We're going to substitute in values for this problem. And I implore you to go ahead and do this on paper and try to do it before you see me write down the answers. But I'm not going to sit here and just do all the answers for you and explain it. I'm just going to write them in. So if I substitute in the value -2, I get 5. If I substitute in the value 0, I get 4. If I substitute in the value 2, I get 3. If I substitute in the value 4, I get 2. And if I substitute in the value 6, I get 1. I just know that. And you can know it too as long as you make sure your math is pretty good. When it comes to algebra type problems, it's usually not the algebra that confuses students. It's the computation of addition, subtraction, multiplication, and division. So make sure your skills are up to par. And if they're not, practice your skills. So these are my values. These are my coordinates that I want to substitute, or excuse me, that I want to plot on my graph. My beautiful, awkward looking, slightly not straight edge graph. But you know, I do the best I can. So the first one is at -2, 5. The next one's at 0, 4. Next one's at 2, 3. Next one's at 4, 2, and then 6, 1. Here's a question some students ask me. What happens if your points go beyond the graph? Well, it's not written in stone. If you wanted to create a longer graph, you could. Just erase that arrow, you know, write a longer line that goes through, a dash mark, close your arrow off. It doesn't have to be 5, 6, 5, 5. It could be 100 on each side. You're not going to do that though because that takes a long time and it becomes very inefficient, but that's a method of doing it. Now, let me get back to what I was going to get to. If I do not connect these points, it is a discrete function in this case. It's a function because it passes the vertical line test, which is something that we talked about before, that I can't draw a vertical line through more than one point. And it's also a function because I don't see the same x value more than once. So hence it's a function. If I decide to connect the dots, which is exactly what I'm going to do because it says graph the equation, it doesn't say plot the points, it says graph it, then it becomes continuous. And by continuous I mean that, you know, it'll go on. It'll go on in both directions. By discrete I just mean discrete little points that aren't connected. And that was my attempt at a straight line again. Now, like I said, picture's worth 1,000 words. What exactly does y equals negative 1/2 x plus 4 mean? I don't know. I'm not here to analyze its feelings. But if somebody asks you that and you draw a representation, a picture, a graph of it, you explain to them what it means. You say, well, the graph goes slightly down, it's slightly skewed, the slope or the gradient is negative, and we're kind of going this way, not dropping too fast, but we're not going anywhere positive. And if we look at the negative values, we can see that it's, going up, going this way. So it's pretty fascinating. Now, another thing to cover, because I said this was a more advanced example, and this was something that we did before. I don't know how many people remember it because you need gentle reminders, and that's what I'm going to have to do, a gentle reminder on whether something's a function and what the domain and range are. Domain is the x values, if you remember, and range is the y values. And one way that a student had me remember, because I used to do something else instead, was he said, oh, D comes before R, doctor, so domain is x, range is y. Yeah, that's fine. I guess that makes sense. So the domain is the x values of this graph. So how far do the x values extend in this graph? Now some people are saying, oh, that's easy. The domain is -2, 0, 2, 4, and 6. And the range is 5, 4, 3, 2, and 1. If it was a discrete function, yes. But since it is a continuous line or a continuous function, that is no longer the case. See, the domain is what x values exist in this graph. Well, here's the question. How far do the x values go this way? How far can you go if you wanted to? Somebody's going to say, well, I can go 100 values. And somebody's going to say, I can go 105 values. And then somebody's going to say, I can go 1,000 values. And somebody else will say, well, I can go infinity. And somebody can say, I can go infinity plus 1. No, you can't go infinity plus 1. You can just go infinity. Infinity never ends. You can keep going all the way, forever and ever and ever and ever, this way. And you can go forever this way. So your domain for this linear function is negative infinity to infinity. It keeps going this way forever, and it keeps going that way forever. That's what domain means. It's your x values. Your range is how low do you go to how high do you go. Now here's the question. If my x value keeps going forever and ever and ever, how low will my y value go? Now somebody's out there is going to say, well, if your x value keeps going this way, your graph's going to keep going down, so that means that your y value will keep becoming less and less and less, a higher and higher negative number. So it won't stop. And that's the answer. It won't stop. It keeps going down. It won't stop. The y value, how low will it go? It'll just go and go and go and go. And it goes on forever. But we don't say forever. There's actually a mathematical term that we use, and it is infinity. But if we keep going down this way, it's not positive infinity, it's negative infinity. And if we, oops, that didn't look like a good infinity sign. And if we kept going this way with the x, forever and ever and ever, what happens to the y value? What keeps happening to the graph? Which way does it go? Up! It keeps getting higher and higher and higher. And as long as I keep going this way, this graph is still going to go up. I mean, it's not going to go up, as high as you necessarily want it to, as fast as you want it to, I should say, but it's still going and going and going and going. Will it ever stop going up? Will it ever reach its limit? No, it won't. It'll just keep going and going. Well, how long does it go? It goes forever. What does forever mean? I'm glad you asked that again. It means infinity. So your domain on this particular graph is negative infinity to infinity, and your range on this particular graph is negative infinity to infinity. Let me just express this right now. When it comes to linear functions, most of the time, your domain and your range are going to be negative infinity to infinity, negative infinity to infinity. There are a couple exceptions, a couple type of exceptions in terms of linear graphs. And we're actually going to be going over that very soon. But with that said, I think that's enough for right now. And what I did was I basically showed you that you have to solve for y, plug in appropriate values. I say plug in up to, or excuse me, substitute up to 5 values in for your table, figure out what the y is for each one, plot them. Now, if you don't connect them, it's discrete, but you have to connect them. If it says graph the equation, it becomes a continuous function or a continuous equation, and then figure out your domain and range. I think most of the time when you first do this, most teachers don't ask you about the domain and the range. Why do I do that then? Because eventually, if you keep taking mathematics, you're going to have to learn this. So you might as well learn it as early as possible, so that when you see it again and you're actually graded on it, you'll say, oh, I've done this 500,000 times. I can keep doing it. Pfft, no problems. Anyways, with that said, that's it for today. Have a great day.